Namaskar. Let's see the one statement given by the Lord Kelvin regarding the measurement. I often say that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of the knowledge, but you have scarcely in your thoughts advanced to the state of science, whatever the matter may be. Lord Kelvin, 1883. So, this was the statement which was given by the Lord Kelvin regarding the measurement. So, let's go to the chapter 11, subject physics, that is units and measurement. This is the second chapter of NCERT. Today we are going to discuss the topic, the International System of Units. As you know that earlier there were scientists which were using the different system of units, and before that also there were ways of measuring. Say for example, if we want to measure the length, then in the early times they were using cubit, hand, button and bamboo and many more system of they were using to compare the length, to measure the length. But there was a problem. When they were sharing their knowledge from one person to another person, so sometimes it becomes quite difficult. So later on, scientists developed a system of units. So different countries, different system of units they were using earlier. You can see here the system of units that is used is, first one is, you can see, that is the CGS system. In CGS system, the unit of length, mass and time are used as centimeter, gram and second respectively. Similarly, in the FPS system, the unit of the unit of length, mass and time are used as foot, pound and second respectively. And in the case of MKS system, the unit of length is meter, the unit of mass is kilogram and the unit of time that is used is second, as in the all cases. Yes, so these were the system of units were used in different countries. Now during the globalization, we all are using the same thing, same units also. So the system of units which is at present internationally accepted for measurement is the System Internationally de Unites, and it is also the called as International System of Units, and in short you can say SI units. So the system of unit that presently accepted all over the world is SI system. Let us see the SI system. In SI system, we are having the 7 base quantities. These are called the base quantities because they are not derived from any other physical quantity. Yes, they have their self origin, that's why they are called the base quantities. And here are the 7 base quantities. The first base quantity is the length, and its name is of the unit is meter, and the symbol for the meter is small m. The second base quantity is mass, and its unit is kilogram and the symbol is kg. The third unit is base quantity is time, and the unit is second and the symbol is small s. So these are the three physical quantities: length, mass and time are used in the mechanics. Now in electric current, we are having the one base quantity, that is the electric current, and its name is ampere and the unit is capital A. It is to be noted here that the symbol for the ampere is taken as capital because it is the name of a scientist. If the unit is in the honor of a scientist, then the symbol is to be written with the capital letter. Similarly, in thermodynamics, we are having the thermodynamic temperature and its unit is Kelvin in the honor of the scientist Lord Kelvin, and the symbol is capital K. And the sixth unit is amount of substance, and that is unit is mole and the symbol is MOL. And the last is luminous intensity, its unit is candela and the symbol is CD. So here the definition of all the base quantities are given here. See the meter symbol M is the SI unit of length. It is defined by taking the fixed numerical value of the speed of light in vacuum C to be 299792458 meter per second when expressed in the unit meter per second, where the second is defined in the terms of the cesium frequency. Similarly, we are having the unit for the mass and other also. At last, you can see there is a one important point. It has been given. The values mentioned here need not to be remembered or asked in the test. So these definitions of the base quantities are not asked in the test. They are just given as a ready reference for you, that how accurate they are and how precise they are. So they are done with a great precision and very high accuracy. Yes, and the base units are revised to keep up with this progress, and these base units are also being revised every time. So here we are having the 7 base quantities. Yes. Now apart from these 7 base units, we are having 2 supplementary units. One is the plane angle, its unit is radian and the symbol is RAD. Second is the solid angle, its unit is steradian and the symbol is SR. Plane angle, as you can understood, it is 2D, and the solid angle, it is 3D. You can see in the figure 2.1 how plane angle and solid angle has been given. But for our purpose, the only requirement is the plane angle. So let us see what is plane angle. Plane angle, it is the ratio of length of arc and the radius. That is, in the figure you can see, suppose that the length of the arc is ds and the radius is r. So you can define the angle subtended at the center is d theta, that is equals to ds upon arc into, that is the in radian. So plane angle, it is the ratio of the length of the arc and the radius. So d theta is equal to ds upon r. What is ds? ds is the length of the arc and r is the radius. Its unit is radian and the symbol is RAD, as you have earlier seen. Let us see that we are having a part of a circle. Length of the arc is s and the radius is r, and the angle subtended at the center is theta. So you can write angle theta is equals to the length of the arc divided by the radius, that is s upon r. Now suppose that there is a one case we are going to discuss. Suppose that s is equal to r, means the length of the arc is equal to the radius of the circle. So if that happens, and you know that angle subtended at the center is given by S upon R. So S is equal to R, so here you can write that is R upon R. So what you will get the value of theta? Theta is equals to 1 radian, because R and R will cancel each other, the value you will get is 1. Or you can also write in the symbol 1 RAD. And even if you are not writing anything, that it is understood that you are representing that particular angle in the SI unit, that is the radian. So here theta is equals to 1 radian, it is understood. And let us see about a point. As we already know the formula, angle theta is equals to arc upon radius, that is theta is equals to S upon R. And you know that if we are taking the circumference of a circle, then the circumference is equals to 2 pi r. 2 pi r divided by r, so that you will get 2 pi. And in earlier classes you have studied a point is of 360 degree, and here you have got a point is of 2 pi radian. So you can compare here, 360 degree is equals to 2 pi, or pi is equals to 360 by 2, or pi equals to 180 degree. So here you have got the one relation between the radian and degree. So you can say that pi radian is equals to 180 degree. So here are the 7 fundamental units or the base units along with 2 supplementary units. Yes. Now the question is why we are using this SI units internationally. Yes. So we are using this SI units. The first reason is that this system of unit is internationally accepted. All over the world, this system of unit is being used. Yes. Second thing, it is a coherent system of units, because if you want to get any other physical quantity its unit, you can get that by dividing or multiplying the base quantities. Say for example you want to get the unit of speed, then that will equals to meter per second, and meter is the and second, meter is for the length and second is for the time. These are the two base quantities. So any derived unit you can get by dividing or multiplying the base quantities. And the third advantage of this is a rational system of units, means one type of physical quantity will have only one unit. Say for example we are having the energy. So whether it is a heat energy, light energy, sound energy, mechanical energy, electrical energy, everyone will have the same unit, that is the joule. So this is all about the system of units that is accepted all over the world. Thank you all of you.